Welcome back to my channel Balvigyan Bharti, and here is your mentor Avilash Sarkar. The earlier videos we have described several ratios which are of single multiple of any angle. If I go with the any multiple of angles, that is if I take 2 theta or 3 theta, I have shown the variation how it has to be and how the things can be derived. In that process, I also described if the angle is measured in clockwise direction, that means the angle if it is measured negative way, and what would be the case and what would be the result that will come from any trigonometric ratio. If I consider any particular trigonometric ratio, how will that trigonometric ratio will act according to the angle. So in that I thought there may be a confusion may arise in viewers mind. So to clarify that, I want to bring one example so that it could give more clarity to the thing that I have described earlier. So in this case, what I will take two angles, that is for negative angle particularly I am saying, because positive is very easy to understand, but negative it bit confusing. So that's why I want to show with an example with a both kind of process. Okay, with the conventional process of thing where the angle is measured only in anti-clockwise direction, that is positive, and clockwise direction if it is that somebody want to do in a manner that angle is measured if it gets clockwise direction, that is a negative angle, how will you treat directly that angle. So be with me so that what I am to trying to make you understand, that can be understood better way. So if I take angle sine of minus 350 degree, and other one I will show sine of, that I have shown you earlier also, but when I will compare these two things, that will be more clear. So one more thing, anti-clockwise any angle is positive. You just remember this orientation. Clockwise any angle is negative. So do you remember? Okay. So for this, the process 1 or case 1, if I can say, where I will use sine of minus theta is equal to sine theta minus sine theta, and using that whatever be the result, I want to do with the same I want to do in a manner that I will not use this formula. This is the standard formula that I have proved how it has came. If I try to use it, what would be the result? And if I don't use it in other way also, result should match. So I want to show you that. So if I do this, so this sine of minus 350 will automatically can be written as sine of 350. Now further, this has to be written as 350, that nothing else than 360 minus 10. What is 360? Sine of 4 into 90 minus 10, and this is sine of, because 4 is an even number, and any even number multiplied by 90 will keep the ratio same, so sine will be sine, and the angle remaining is 10, and this falls on 1 2 3 4 360 and minus 10, that means the angle is coming here. So for that another minus will come. If I take this, for this already there is a minus, for this sine of minus theta. Now another minus will come, as because the angle, this angle comes to fourth coordinate. So if I calculate minus and minus plus, so ultimately this will turn into sine 10. So that means ultimately sine of minus 350 is giving you sine plus sine 10 degree. Remember this result. Now the case 2 where I will not use sine minus theta is equal to sine theta. If I want to do it directly, sine of minus 350 I am writing here again. So this is, I can write sine of minus 4 into 90 plus 10, that I can write. Okay. Now, as per the earlier understanding, what is the case? Any event multiplied by 90 will keep sine as a sine. If I follow that rule, sine will be sine. Now come to the selection of the sine before the sine ratio, means trigonometric ratio. Minus, that means any angle I am going clockwise, minus 4 into, that means clockwise I am rotating up to 360 degree. Then after this I am rotating up to this is 360 degree, that means this is 360. So that will the same as denoted by minus of 4 into 90, that means clockwise I am rotating 360 degree. Then after it is plus 10, that means I am rotating back anti-clockwise by 10 degree. This is your 10 degree. So ultimately this will represent by the final position this. So where this final position comes? First coordinate. First coordinate sign is what? Positive. So ultimately it will turn into this. So sine of minus 350, the earlier result also plus sine theta. This case also it is sine plus sine theta. So any way you do, whether you will use sine of minus theta is equal to minus sine theta, or you do the previous process that I have shown, that sine of n into 90 plus or minus theta. Accordingly we have to choose the thing, and if it is even, sine will be sine, and plus or minus wherever it is going, that angle wherever it is going first, in which coordinate except first and second coordinate, sine will be minus. If it is first and second coordinate, sine will be plus. So that way the things will give you the same result. Now take another example, the example of 370. So I will first solve it by case 2, sine of, why I am taking this you will come to understand. If I follow the same, sine of minus theta is equal to minus sine theta, that way straightway I can say sine of 370. Now I will not consider this negative, only I will consider this, because negative already came into picture, so I will not think on that. Though further, if I forget this minus, so this is assumed to be the same as earlier that we learned in the first phase of the theory. So sine of this can be written as 4 into 90 plus 10. Okay, so sine will the minus will continue. So 4 into 90. So that means it is anti-clockwise. I am going 4 into 90, then plus. So that means it is going in the same direction, anti-clockwise, and the final position is this one. This is 10 degree. So this has moved. So ultimately this angle comes in first coordinate. So sine in first coordinate, sine will be for 4 into 90, sine will be sine, and for first coordinate, sine will be positive. So it will become this. So ultimately sine of minus 370, the ultimate result is minus sine 10. Okay. So remember this result. Now let me check. If I go directly, instead of doing that, I will write 4 into 90 minus 10. Okay. So now this is 4 into 90 means clockwise it is moving into 360 degree. Now minus 10, that means it is moving further clockwise to 10 degree. The final position is this. So for 4 into 90, sine will be sine. Okay. And further, this sign only denotes which way it is rotating. So after that, there is no use of this sign. Okay. So 4 into sine will be sine. Okay. Now this total angle, it is lying on fourth coordinate. So only I will bring minus for that fourth coordinate, and the angle is 10. Understood? So this way also result comes the same. So this signs will not be considered again and again. For the case, if I consider the first way of doing that, so only this will decide the first, this even or odd, sine will be sine, and after that the total angle where it is lying. If it is lying in the fourth coordinate, for whole thing there will be a negative sign outside, and the angle which is remaining after distributing it into 90 plus theta, so that theta will come directly. Understood? So this way the things can be thought in different way. Either you can use that one if it is easy for you to remember sine of minus theta is equal to minus sin theta, cos of theta minus theta is equal to cos theta. For tan, as any of this is negative, the tan will be negative. So this is the thing you can remember. For to clear the concept, I thought it should be described or discussed. Okay, now further moving to more you can say the relations or identities or formula that has to be discussed. But this case, the earlier all cases we have taken the triangle as a right angle triangle, and we have drawn the formulas basis of the right angle triangle. But this case, the triangle that we will select it a generalized triangle, that is a scalene triangle. Okay, scalene triangle. So this scalene triangle means where the sides of the triangles are not equal. None of the sides are identical to each other. So if I consider any generalized form, this is C, this is A, and this is B, and I wish to describe this C, that vertex C will represent angle C here, vertices B will represent angle A here, and B will represent B here, and the side which are representing that's opposite to the angle will be represented with the smaller smaller letter of the same angle. So that means the angle B, the front side will be represented by small b, this will be A, this will be C. So this will be my representation during establishing the formula. So this on this basis I will draw the first phase of the thing, will call it a sine law. The first thing I will describe as a sine law. The law says this is A by sine A, that means side by sine of the angle, B by sine B equal to C by sine C. This can be proved, but this is the formula. This is called the sine law of trigonometry. So how can it be proved? So let me draw it. Draw the triangle again. Only this time I will denote the vertices, and accordingly things will be same as I described. Just keep it in mind. Whatever I have described earlier, I will assume to be same during this derivation. So what I will do, I will put a vertical from this onto the opposite side AB. So this I am assuming is a right angle triangle, and this height is H. This part of the thing where I will assume this is point D, where it is intersecting with the other side D. So this part I am taking X. So this is obviously B, C minus X. This is A, as I said earlier, this is B. Okay, now trying this triangle. and if I assume this is B, as I have already said, this is A, taking sine of B. What is that? Sine of B, that means height by hypotenuse, h by A. Okay, so this is my first equation, and similarly if I, this is again a right angle triangle, if I take the sine of A, if I take, so that will give you height by hypotenuse h by B. Okay, this may be the second equation you can say. From these two, if I equalize or if I divide these two, so I will divide sin A by sin B by sin A, so that will become h by A divided by h by B. So h will be cancelled out, this will be B by A. So ultimately from there I can say, if I brought on the top of sin A, so the same way B will come other as a numerator on the denominator sin B. So the first phase of the equation is proved. Now will it not be possible to do the same way if I draw it from there? So when I am drawing from C, which are the angles come into picture? A and B, because these are dividing A and B in parts. If I draw from B to A, so as a common sense you can say this will come A and C. So similarly, if I consider the perpendicular dropping from B to the other side, so as this is this angle coming, so from there we can say A by sin A obviously be equal to C by sin C. So from these two relations I can say that A by sin A is equal to B by sin B, A by sin A is equal to B by sin B is equal to C by sin C. So this proves the sine law. Understood? The second part of the theory is the cos law. The second part of this theory is the cos law. Cos law. Okay. In this there are three relations. So one by one I will prove. Other two or the third one automatically will prove. So I will use the same drawing, same you can say same drawing I will use, and same triangle also I will use, and here the sides are also to be same, and the partition I will make. I will drop a perpendicular here, and accordingly the partition I will assume the same. This is x, c minus x. This will be used for that law. So if I consider this, I have already considered this is h. So from here, from this triangle, this is right angle triangle, from this triangle what I can say, this is hypotenuse, this is vertical, this is the base. So Pythagoras formula says for a right angle triangle, hypotenuse square is equal to height square plus base square. From this is I can consider the first equation, and if I consider this triangle to be as the same, this also having a right angle triangle as being this the common vertical to this side. So this is also a right angle triangle. From here you can say the hypotenuse square, that means b square is equal to height square plus c minus x whole square. This is second equation. So now if I eliminate h from this, so this will eliminate. So this is a square minus b square is equal to x square minus c square minus x square minus plus 2cx. So now xx will be cancelled out. Ultimately if I write minus c square one side, this is 2 into cx. So this will be your third equation. Now again consider cos of b. Cos of b is equal to what will you give? X by a. X by a. So x is equal to a cos of b. The same I can replace here. So if I replace it here, so it become a square minus b square minus c square is equal to 2 into c into a cos of b. Is c into x, a square by a square plus x square, b square is equal to a square plus c minus a square minus b square, x square minus c square is equal to this. So, sorry, this will be plus, no? C I have taken this side, so this will be plus. So if I replace it here, so this become this one. So I can array it accordingly. So if I write b square in one side, so only b I will bring on the other side, and other all terms I will bring on one side. So this will become a square plus c square 2ac cos of b. Now why I have written like that, I want to put it in a manner so that it will give a common kind of representation. That means if I take angle b, so my side of b will come on the other side, and the other two sides will come as a square in the one side, and the combination of AC will come along with the b side. So this will be the, so from there if I want to represent the other sides, that means if I take a square on one side and keeping the other two sides, that will be related as same way as it has there. So 2BC, and the angle will come, it will follow the side which is on the other side. So if I want to prove it like that, I can prove it here also. The ultimate equation, the third equation came like that. Now let me write it. If I consider this angle cos of A, if I consider, so what will come? That is c minus x by b. So from here x will be c minus b cos A. You see it, b cos A, c minus x, so x is equal to c minus b cos A. So replace it here, c minus b cos A. Okay, so this will be like that. Now use this part of the board. This is become a square minus b square plus c square is equal to 2 into, if I remove the bracket, this will become 2c square minus 2bc cos A. Now if I again, so 2c square, if it is come this side, this will be c square is equal to minus 2bc cos A. Okay, so now a square is equal to b square plus c square. I am bringing this on the other side, 2bc cos A. Now see the similarity. This I told from the similarity, the earlier I have brought the equation, that was b square is equal to a square plus c square minus 2ac cos of b, and now this time this is coming as a formula. So with the same description or with the same drawing that is being drawn here, with the same arrangement of the drawing, I made two equation. Okay, taking once this side and other type this side. So these are two similar. You can understand easily when cos A is coming this side, when cos B is coming. So the third equation, if I say, it can easily be written as, isn't it? So these are the three formula of cos, these are called the cos laws. This can be easily be used. So then generally, if I want to represent the cos of angle A, that will give you b square plus c square minus a square by 2bc. Okay, on cos A, then the minus will be a square and there will be no a. Cos B, similarly, it will be a square plus c square minus b square by 2ac. And the third one, cos C, is equal to a square plus b square minus c square by 2ab. So this will be the three laws of cos. The earlier we have seen the three laws of sine. So this is end of the theory. And then from the next class, I will start solving problem on the theories that I have taught already. Okay. So be with me and just follow my classes. Try to subscribe more and learn more. Thank you.